Alrighty, so for today we are going to take a look at section 3.5, which is going to be solving systems in three variables. So if we have three variables, then we also have to have three equations. So now when we have three equations and three variables instead of just two, then that's going to change the geometric area in which we're solving. So if we have two variables, x and y, we know that that's a normal coordinate plane that you can put on a piece of paper. However, when you add that third variable, z, in, that means that you're now talking about a three-dimensional space. So we're not just talking about a point on a coordinate plane like we've done forever and ever and ever. We're talking about a point in space now. So we've got length, height, width, all three dimensions. So these are some examples of what it can look like. So when we're talking about those three variables, that means we are now talking about a plane in space instead of just a two-coordinate grid on a piece of paper. Now, we're looking for where all three of those planes will intersect, and there are a lot of ways that that can happen. Now, you can have no solution. It is possible that if you have three planes, that they don't all ever cross in one single point or even any point at all. So this first example is no solution. So if we look, we have three planes here. So we're looking at this right here, three planes, and you can see that right here, two of the planes cross, here, two of the planes cross, here, two of the planes cross, but we don't have anywhere that all three of the planes cross. Then if we look at this one, this middle one, same thing. We've got a plane going across here, we've got a plane going across here, and then we have that vertical one that is cutting through both of our planes, but there's nowhere that all three of them come together in the same place. So then, this last one is where all three planes are parallel. If they're all parallel, then nothing is ever going to cross either of the other two. So all three of those would be examples of no solution. Now, we can also have an example of one solution. So if you look at this example right here, then we can see that we have this one plane here that looks like it's just laying flat. Then we have these two planes that look like they are crossing each other, and those two planes crossing each other are being cut by this plane that's laying flat. Therefore, they meet in this one single point, and only that one single point. So that's the only point in space that all three planes come together. Now our last example is an infinite number of solutions, or what we called IMS when we did the 2x2 systems. Now that's where we have all three planes and they come together kind of like a fan. And so we can see that all three planes come together, but they form a line where they all come together. So there are all kinds of points there, an infinite number of points where all three planes are crossing. So, no solution, one solution, or an infinite number of solutions. Now, we are primarily going to be dealing with the one solution. That's going to be the most common thing that you're going to run across, because people who create math textbooks and math problems tend to focus on those because they're trying to teach you how to solve for where those things would come together. Now, it's not to say that we can't see the other ones, but we will primarily see the one solution. Now, a solution of a system that has three variables has to have three answers. So we call it an ordered triple. So it's just like a coordinate point, except we now have three numbers. And it always has to be in this order. It's got to be x, then y, then z. If those are out of order, then anybody looking at it is going to assume that those numbers stand for the x first, the y second, and the z third. And if you don't have them in that order, then it's going to be interpreted incorrectly. So if that ordered triple is a solution to every equation in your system, then that means that those numbers for x, y, and z, when plugged into each equation in the system, will work mathematically, and you will get whatever each equation equals. So you can plug it in, do the math, check your answers. Now, we have three main steps for solving by elimination. And it sounds complicated. Oh, I'm sorry, 4 steps. It sounds complicated, but it's actually very systematic. So we're going to talk about elimination for today, and then we'll do a separate lesson over substitution. So step 1 is we're going to rewrite the linear system in 3 variables as a linear system in 2 variables by using the eliminations method. So what we're going to do is we're going to use elimination to get rid of either the x's or the y's or the z's. And we're actually going to do that twice, getting rid of the exact same variable both times, and then that's going to give me 2 new equations that now only have 2 variables instead of 3. Once I have only 2 variables, then I can solve it just like we did back in 3.2, where we can use elimination, substitution, whatever it is they want us to use. So we're going to stick with just elimination using the elimination method for both step 1 and step 2. So step 2 is to take the new system with the new equations that now only have 2 variables, and we're going to solve it using the same method that we did in 3.2. We're going to use elimination, and we're going to be able to eliminate one of the 2 variables that we have left. Once we have that, then we're able to solve for that one variable that's left. Then we move on to step 3, which is going to be to take the value that we got in step 2 and substitute it into one of the original equations. So when we do step 2, we should actually get the answer to both of those variables that were left, and we'll be able to substitute those values into the original equations. We only need to do one of them, any of the 3 original equations, and then that will allow us to solve for the 3rd variable, whatever's left. Then our last step, once we have answers for all 3 variables, is to simply plug it back into all 3 equations and make sure that it works in every single equation in your original system. Now, there are a couple of special things that you could run across, and that's going to be if you obtain a false statement such as 0 equals 1 in any of the steps, then you can stop right there and you know that the system has no solution. So just like in 3.2, we talked about if you get a false statement or not true. So not true means no solution. Of course, if you get something like 0 equals 0, so you get a true statement, such as 0 equals 0, or it could be 1 equals 1 or whatever, then the system has infinitely many solutions. So always keep that in mind. So true is IMS. All right, so let's take a look at an example. Now, I actually want to save this first example for later in the lesson. I want to show you a more typical problem because in this one, something special is going to happen, and it's actually kind of unusual. So I'm actually going to start with number 2, and then I'll come back to number 1 at the very end. So what we want to do is we want to figure out which variable that we can cancel easily. So just like in 3.2, we want to do the least amount of work possible. I don't want to have to change all kinds of stuff if I don't have to. So I want to look at my x's, my y's, and my z's, and I want to try to determine what is going to be the easiest to get it to cancel. Now remember, I'm going to have to get the same variable to cancel twice. So I'm going to pick 2 equations to get one of the variables to cancel. Then I'm going to pick another set of 2 equations and cancel the same variable. So when I look at these 3 equations, my x's, that doesn't look too difficult. I could very easily take either one of these and turn it into a negative 2x to cancel with that one. I'd simply multiply the first or the second equation by negative 2. Okay, well that's not that hard. If I look at the z's, that one's a little bit more difficult, so I definitely wouldn't want to do the z's. Now it's not that difficult. I could multiply this by a negative 3 to get it to cancel with that 3z, or I could multiply this by a negative 2 to get it to cancel with that positive 2z. Again, not that difficult, but look at the y's. If I look at my y's, then I can see I can get that to cancel twice with absolutely no modification. I can get those two to cancel just the way they are, and then I can also get those two to cancel just the way they are. So since I don't have to do any modifying to the y's to get them to cancel, that's the variable that I want to use because it's less work. So I'm going to label these as equation 1, equation 2, and equation 3. Now, the key to getting these problems is go slow and keep it organized. If it gets messy or you try to go too quickly, that's where the simple little math errors happen. And one little math error can mess up the entire problem. So you want to go slowly and carefully, and please, please, please have a calculator to check your little math. Okay, so let's start with this. So the first thing I want to do is I want to cancel those two. So I'm going to take equation 1 and equation 2 just the way they are, and I'm going to rewrite them. So equation 1 is x minus y plus z equals negative 1. Equation 2 is x plus y plus 3z equals negative 3. And then I'm going to combine these together, and when I do, my y's should cancel. That's what I planned. So if I combine my x's, since that's a 1x and a 1x, that gives me 2x. Then my negative y and my positive y, those are going to cancel. They're gone. Then if I have my 1z plus 3z, that gives me plus 4z. And then negative 1 plus negative 3 gives me negative 4. Again, if you are even the slightest bit unsure, use your calculator for the math. You don't want to get these problems wrong and be confused and frustrated because you made a little math error. All right, so now we're going to put that on the back burner. We're going to call this new equation, equation 4. Okay, so we're going to leave that alone for a minute, and we're going to go back to our originals, and I want to pick two different equations and cancel the same variable. So I canceled y the first time, I need to cancel y again. So I see that I can also cancel y there without modifying anything. So that's going to be equation 2 and equation 3. So I'm going to take equation 2 just the way it is, which is x plus y plus 3z equals negative 3. I'm also going to take equation 3 just the way it is, 2x minus y plus 2z equals 0. And then I'm going to combine those together as well. Okay, so if I have 1x and 2x, that gives me 3x. Then my positive y and my negative y cancel out, they're gone. Then I have 3z plus 2z is plus 5z. And then I have negative 3 plus 0 is negative 3. Okay, so this gives us another new equation. So this is going to be equation 5. So I'm going to label that. Okay, so now this is the end of step 1. We've gotten rid of the same variable, and we now have, let's go back up to our steps here. Okay, so we now have only 2 variables left. We have x and z. So what we need to do now is step 2. We need to take that new equation, those 2 new equations, and we're going to set up a system. So I'm going to start by just rewriting them. So I have equation 4 was 2x plus 4z equals negative 4. And then my new equation 5 was 3x plus 5z equals negative 3. Okay, so now with these 2 new equations, we want to do elimination, just like we did back in section 3.2. So then, that means I need to cancel either my x's or my z's. Now, neither one of these is going to cancel the way it is, because we've got a 2 and a 3. Remember, to get them to cancel, we have to have the same number, but opposite signs. And then for the z's, we have a 4 and a 5. Those aren't going to cancel either. So I'm going to need to modify both equations because I can't turn 2 into 3. I can't turn 3 into 2. I can't turn 4 into 5 or turn 5 into 4. So I've got to change both equations. So I'm going to take the x's and I'm going to realize that I can change both of those x terms into 6's. So if I want 2 to become 6, I need to multiply by 3. If I take 3 and turn it into 6, I'm going to have to multiply by 2. But just like we talked about before, in order for those to actually cancel, they've got to have opposite signs as well. So I need to either make the 3 negative or I can make the 2 negative. Only one of them though, because I want one of them to be a positive 6x, I want the other one to be a negative 6x. So I'm going to go ahead and make the second one the negative. And so then when I multiply that through, remember it's got to multiply by everything. So that's going to give me 6x. That's going to give me plus 12z equals, and then that's going to give me a negative 12. Okay, so there is my equation 4 modified. Now I want to go ahead and modify that equation 5. So then that's going to give me a negative 6x. Then we have a negative 10z equals a positive 6. All right, so now that I have those x's ready to cancel, I'm going to combine those two equations. So positive 6x, negative 6x, they cancel and they're gone. Now my z's, if I have a positive z plus a negative 10z, or 12z minus 10z, that gives me 2z. And then negative 12 plus 6 gives me a negative 6. Then I can very easily solve for z. So divide by 2 on both sides, and that gives me that z equals negative 3. So once I have that first variable's answer, then the rest is just plugging things back in. So let's go back to our steps real quick and see how far we've gotten. So we're part of the way through step 2, but we haven't finished it because it says solve the new linear system for both of its variables. I have one of them, but I need to get the other one. So let's go back to our problem. So if I have z, then in my new system, my equation 4 and 5, I have x and z. Well, I know z, but I don't know x. So I'm going to take that value I got for z right here, and I'm going to plug that into either equation 4 or 5. And you can totally choose whichever one you prefer. I chose to use equation 4, but ultimately it's not going to matter. So if I take equation 4, so equation 4, so I'm going to rewrite it so we know exactly what we're dealing with. So we have 2x plus 4z equals 4, because this is our equation 4 right here. Then I've rewritten it. Now I need to take this negative 3, and since that's z, I'm going to plug it into the z in my equation. So then that's going to give me 2x plus 4 times negative 3 equals 4. So then I can solve this. So I'm going to keep my 2x, but then 4 times negative 3 is a negative 12, and that still equals 4. Then I can add my 12 to get rid of it, and then that's going to give me 2x equals 16. Okay, so then, oh wait, I am missing something. That equation 4 is supposed to be a negative 4. That makes a big difference. Okay, so if I put my negative in there, then this is no longer going to be 16. Ooh, that was erasing a little too much. Get rid of my 16 there. Okay, so then if I have negative 4 plus 12, then that's now going to give me 8. That's better. All right, so be careful when you're writing your equations. All right, now to solve for x, all I have left to do is divide by 2. All right, so that means that x equals 4. Now, if I hadn't caught that I left off that little negative 4 right there, that could have completely messed up my answer from here forward. And then it gets a little bit frustrating. So, like I said, go slowly and carefully. All right, so now I have two answers. I have an answer for z and I have an answer for x. The only variable I don't know is y. So if we go back to our steps, we have now finished step 1. We've got it written in two variables. We have now solved for both of those variables. Now step 3 is to substitute the values found in step 2, so that's my x and my z that we just found, into one of the original equations. So either equation 1, 2, or 3. And then that's going to allow us to solve for that one last variable that we don't know. So going back over here, I can choose equation 1, 2, or 3 to plug in those two answers that I know. Now remember, y is the one variable I don't know. So I want to look at these equations and decide which one do I want to use. Well, since I'm solving for y, I would like to, if possible, avoid the negative. And I notice that here I have a positive y, which means that kind of seems like that's going to be an easy one for me to solve for. So I'm going to choose to use equation 2. You technically could use any of the 3 original equations. So I'm going to start by just rewriting equation 2. So equation 2 was x plus y plus 3z equals negative 3. Okay, now that I have that rewritten, I'm going to take the two answers that I know, x and z. So x is 4, so we're going to plug 4 in right there. And then z is negative 3, so we're going to plug that in right there. So we have 4 for x plus y plus 3 times z, which is negative 3. And then that equals negative 3. So now we're going to focus on just that, and we're going to solve for y. So we're going to leave that 4 alone, plus y, but then we have 3 times negative 3, which is negative 9, and that still equals negative 3. Now, I have some like terms. I can combine the 4 and the negative 9. So I'm going to leave that positive y, but then if I do 4 minus 9, that gives me negative 5, and then it still equals negative 3. All right, now that I have that, I need to add the 5 to cancel it out. Make sure I add it on the other side as well. And then that gives me y equals 2. So now if we look, we have answers for all 3 variables. We have x, we have y, and we have z, which means I've got everything I need for my answer. Now remember that my answer should be in a specific order. I know that I'm going to have 3 numbers. It needs to be x, then y, then z. So my x value is 4, comma, my y value is 2, comma, my z value is negative 3. So that is my final solution. And then you can take those values of x, y, and z, and you can plug them into any of these original equations, do the math, and you should come out with these numbers once you're done. All right, so that is our basic 3x3 or 3 variable system. So let's take a look at a few more of those. Now, I'll be honest with you, these problems are a little bit lengthy. You can see we did a lot of work for that answer, but it's also very systematic. So if we just follow the steps and work slowly and carefully, we should be fine. All right, so like I said, we're going to come back and pick up problem number 1. Let's take a look at problem number 3. Okay, so again, I want to start off by looking for what is going to be the easiest thing for me to cancel. Now remember, I've got to cancel the same variable twice. So if I look at the x's, those really aren't too bad. I've got the positive x and the negative x, those will cancel just the way they are. Or I could take this 2x and then multiply this by 2 to get a negative 2x. That would cancel. That sounds pretty easy, but let's see if there's anything easier. If I look at my y's, again, not too hard. I need to be careful though, because these don't cancel the way they are. They're both positive. Now, if I wanted to modify one of them, I could multiply, let's say, this one by a negative 1. Then that would give me a negative y, which would cancel with my positive y. That's okay, I could do that. And then I could take this and cancel it with either one of these, as long as I multiplied one of them by 2. Okay, again, not too bad, but I would have to modify both times. And if I look at my z's, well, either one of the top two equations could be canceled with the bottom one, depending on what we multiply that bottom one by. If I multiply this by a negative 2, then it would cancel with this. If I were to multiply this by a negative 3, then it would cancel with that z. So, all of that aside, it seems to me like the x's are probably the easiest to cancel, especially since I have a set that's ready to go right away. So that's where I want to start. So I'm going to go ahead and label my equations, equation 1, equation 2, and equation 3. So then, because equation 1 and equation 3 have the x's already set up to cancel, I'm going to start there. So I'm going to take my equation 1 exactly as it is, x plus y plus 2z equals 3. Ooh, that's a horrible z. Let me try that again. Z equals 3. There we go. Then I'm going to take equation 3 just the way it is, which is negative x minus 2y plus z equals 10. Then I'm going to combine. So sure enough, 1x and negative 1x, those are going to cancel. Then I take my y's. I have positive 1 and negative 2, or 1 minus 2. That gives me a negative 1y, or just negative y. All right, then I have 2z plus 1z is 3z. And then 3 plus 10 is 13. Okay, so that is what we are going to call equation 4. Now remember, we need to go back up to the originals, and I canceled x in that first little step there. So I need to cancel x again. Now, I haven't used equation 2 yet, so I need to make sure I do that. So I'm going to take equation 2, just the way it is, 2x plus y plus 3z equals 7. And then, since I have a positive 2x here, I need a negative 2x to cancel it. So the easiest to modify is going to be this one, because in order to get a negative 2x, all I have to do is multiply by 2. So if I do 2 times equation 3, so that means I need to multiply everything in equation 3 by 2. So then I'm going to go ahead and write that up here. So if I multiply this, equation 3, by 2, so multiply everything, then that's going to give us a negative 2x. That's going to give me a negative 4y. It's going to give me a positive 2z equals a positive 20. All right, now I can go ahead and combine my equations, and the x's should cancel like I planned. Positive 2x, negative 2x, those are gone. Then I have positive 1y and negative 4y. That gives me a negative 3y. Then I have positive 3z, positive 2z is a positive 5z. And then 7 plus 20 is 27. All right, so this is going to be my new equation 5. All right, that's step one. I now have two equations that have the same two variables, y and z. The x's are gone in both of them. So now I'm going to rewrite that as a new system. So equation 4 was negative y, or you can leave the 1 in front of it if you'd like, plus 3z equals 13. And then equation 5 was negative 3y plus 5z equals 27. Okay, so now I want to ignore that for a little bit, and I want to solve this little mini system. So that means that I need to either cancel the y's or the z's. And I'm thinking the y's look easier because I can take that top y, the negative y, and I could change it by multiplying to cancel with the negative 3y. So this negative 3y, in order to get it canceled, needs to be combined with a positive 3y. So if I want this to become positive 3y, well, I need to change the sign, which means I've got to multiply by a negative. So then if I take that times a negative, then I also need it to be a 3, so I multiply by negative 3. Now that means multiply everything by a negative 3. So negative 3 times negative y, that's positive 3y. Negative 3 times positive 3 is a negative 9z. And then negative 3 times our positive 13 equals negative 39. Now, I don't need to modify the bottom equation at all because I've got my positive 3y that I just created, and I already have a negative 3y here, so those are going to cancel just the way they are. So I'm going to go ahead and bring equation 5 over and change nothing. And then I'm going to combine those two equations together. So positive 3y, negative 3y, those are gone. Then negative 9z plus 5z is a negative 4z equals negative 39 plus 27 is going to be a negative 12. All right, so now I'm down to a single variable, which means I can solve. So I want to get rid of that negative 4, so I'm going to divide by negative 4. And then that's going to give me z equals a positive 3. So great, I've got one answer, so that means the rest is just plugging in and working from there. So I'm going to take that z. So remember, we are now done with step 2. We need to take, or actually no, we're halfway through step 2. We have z. We need to find the other variable in our 2 variable equations. So go back to either equation 4 or 5. And I'm going to plug that z in. So I'm not sure it really matters here. I'm going to say since all I have is a 1 in equation 4 in front of the y, I'm going to go ahead and choose equation 4. So you could choose equation 5 if you prefer. So if I take equation 4, which was originally negative 1y plus 3z equals 13. And I need to plug this 3 in for z. So that's going to give me negative 1y plus 3 times 3 equals 13. All right, so this gives me negative 1y plus 9 equals 13. Then I need to subtract my 9, which is going to give me negative 1y equals 4. And then I have to get rid of that negative 1, so I divide. And that now gives me y equals negative 4. Okay, so now I have 2 of my answers. I have y, I have z, all I need now is x. So that's when I'm going to go back up to the very top, and I'm going to pick one of these original equations. So we have to decide which one do we think is the easiest. So I kind of liked that in equation 1, everything was positive, and the numbers were all pretty small. In fact, 2 of them the x and the y don't have any number in front of it at all. So I chose to use equation 1. Again, you can use whichever one you want. So I'm going to rewrite equation 1 down here. So I'm going to go off to the side here so I don't run out of room. So equation 1, normally I would put it right here beside, but it's going to get squished if I do. I wrote a little bit too big. So equation 1 is x plus y plus 2z equals 3. And now, I know that I need to plug in the two answers I have. So I know that z is 3, so that's going to go there. I know that y is -4, so that's going to go right there. And so then, that gives me x, and then since y is -4, then that's really just -4. And then I have plus 2 times z, which is 3. And then that equals 3. So then let's focus on this. X is our only variable now, so we can solve for it. So we have x minus 4, and then 2 times 3 is 6, and it equals 3. Now I can go ahead and combine these two together. So that's going to give me x plus 2, because -4 plus 6 is 2, equals 3. Then subtract my 2 from both sides, and x equals 1. So now I have all three variables, which means I can write my solution and check my answer. So my solution, remember, is going to be x, then y, then z. So x we found was 1, y is -4, and z is 3. So there's our solution. Now if you take those x, y, and z values and you plug them into your original systems, do the math, the first equation should come out to 3, second should come out to 7, third should come out to 10. All right, so that is number 3. Let's take a look at number 4, and then we'll go back up and pick up number 1, and you'll see why number 1 is a little bit special. All right, so in number 4, again, we want to find which variable would we have to do the least amount of work to get it to cancel. And I kind of like the y's, because you've got a -2y here and a positive 2y here. Great, those will cancel just the way they are. I love when that happens. Then we can also take this and simply multiply it by 2, which would give me a -2y, and then that will cancel with the third one. So that sounds like the best bet to me. It's not what we have to do, but to me it seems like that's going to be the easiest. So we're going to start with the ones that cancel just the way they are. So equation 1, equation 2, and equation 3. So we said that equation 1 and equation 3, the y's would cancel just the way they are. So that's where we're going to start. So equation 1 was x minus 2y plus 3z equals 12. Then equation 3, just the way it is, 2x plus 2y minus z equals 4. And we're going to combine those together. So 1x plus 2x is 3x. My y's cancel. One's positive and one's negative. They're gone. Then I have 3z minus 1z is positive 2z. And then 12 plus 4 is 16. All right, so that's equation 4. All right, now we go back up to the originals and we cancel out y again. So this time, though, I want to take this, equation 2, and I want to multiply it by 2, and then that will allow it to cancel with that positive 2z. So we are going to take 2 times equation 2. And so then that means 2 times 2x is 4x. 2 times negative y is negative 2y. And then 2 times negative 2z is a negative 4z equals 2 times 5 is 10. Then we are going to take equation 3 just the way it is. So 2x plus 2y minus, and remember that's technically a 1z, equals 4. And I'm going to combine those all together. So 4x plus 2x is 6x. Then negative 2y plus 2y is 0. Those are gone. Negative 4z plus a negative 1z is a negative 5z. And then 10 plus 4 is 14. All right, so that is our equation 5. Okay, so now I want to rewrite equation 4 and 5 in its own system, and then we'll look at how to solve that best. So equation 4 was 3x plus 2z equals 16. Equation 5 is 6x minus 5z equals 14. So now I want to decide if the x's or the z's will be easier to cancel. And I'm thinking definitely the x's, because I can take this and turn it into a negative 6 to cancel with that by simply multiplying it by a negative 2. So then if I do that, I'm going to have negative 2 times 3x is negative 6x. Negative 2 times positive 2 is a negative 4z. And then negative 2 times positive 16 is going to be a negative 32. All right, then equation 5 doesn't need to be modified at all because I have a positive 6x to cancel with this negative 6x. So I'm going to bring it over just the way it is. 6x minus 5z equals 14. And so then when I combine those together, negative 6x and positive 6x cancel out. Then we have negative 4z plus negative 5z equals a negative 9z. And then equals negative 32 plus 14. If you grab your calculator, that is going to give me a negative 18. Now all I have to do to solve for z is divide by that negative 9. And that's going to give me that z equals 2. So there's the first answer of my 2-variable system. I have z. I don't yet have x though. So I'm going to go back to either the original equation 4 or equation 5 and plug that value for z in the equation. That will allow me to solve for x. I'm thinking I'd kind of like to use the original equation 4. The numbers on the left side are a little bit smaller. The number on the right is a slightly bigger, but not enough to really make a difference. So I'm going to take that original equation 4. And so original equation 4 was 3x plus 2z equals 16. And now we need to take this value of z that we just found and plug it into the z. So that's going to be 3x plus 2 times, we said z was 2, and then that's going to equal 16. So now we can do the math and solve for x. So we have 3x plus 4 equals 16. I need to subtract my 4, which gives me 3x equals 12. Then divide by 3, and x equals 4. Okay, I now have two of my answers. I have x and I have z, but I need y. Now the only place we had y, remember, is up at the top in our original equations. So I want to pick one of those three original equations and plug in what I know and solve for y. So since I'm solving for y, I want to look for what's going to be the easiest equation to solve for y. Now, you could say I want to do this one because there's no number in front, but there is a negative, and a lot of us like to try to avoid the negatives. So if we want to avoid the negative and we're solving for y, I'm thinking that this probably looks like our best bet. It's the only equation that has a positive y term. So if we want to go that route, then we're going to copy down our equation 3, and then we'll fill into it. So equation 3 was 2x plus 2y minus z equals 4. Now, we're going to take what we know and we're going to plug in. So 2x, so 2 times, and we said that x was 4. Because remember, we're taking this 4, since that's x, then we're putting that in for x. Then we said that z was 2, so we take this 2 and we put it in for the z. All right, so we have our 2 times 4 plus 2y minus z, but z is 2. And then that equals 4. So now let's simplify this and figure out what y is. So 2 times 4 is 8 plus 2y, and then that's just minus 2 equals 4. Then I can take my positive 8, subtract 2, so I'm going to leave my 2y, and then 8 minus 2 is going to be positive 6, and then that equals 4. So now subtract my 6, and I get that 2y equals negative 2. And then the last thing I do is divide by 2, and I get that y equals negative 1. So there are my 3 answers. I know x, I know y, and I know z. So I can go ahead and write my solution. So remember, x, y, and z. So x is 4, y is negative 1, and z is 2. All right, so that is going to be the most common type of problem that you see. Now, let's go back and take a look at problem number 1, and you're going to see why that one is a little bit special. Now, the nice thing about number 1 is something unexpected is going to happen, which is going to make our life a little bit easier. So, following the same steps that we did for all the other problems, we want to start out with what is going to be the easiest variable to cancel. And I'm thinking, obviously, the z, because all of them have either a positive 1 or a negative 1 in front of them, which means I don't have to do any modifying at all to get my z's to cancel. So that's great. So I want to definitely stick with my z's. Now we have equation 1, equation 2, and equation 3. So I say first thing we do is take those two. So equation 1 and 2, because the z's are going to cancel just the way they are. So I'm going to take equation 1, e, which is 2x minus y plus z equals 4. I'm going to take equation 2 just the way it is, x plus 3y minus z equals 11. And I'm going to go ahead and combine those. So then when I combine, I have 2x plus 1x is 3x. Then I have negative 1y plus 3 is a positive 2y. And then positive 1z and negative 1z add together to give me 0, and those are gone just like we thought they would be. And then 4 plus 11 is 15. So there is our equation 4. All right, now going back to my originals. I can also take this positive z and this negative z, and they will cancel. So without having to change a thing, I'm going to take equation 1 just the way it is, 2x minus y plus z equals 4. And I'm going to take equation 3 just the way it is. I'm going to have 4x plus y minus z equals 14. And I'm going to combine those together. So then 2x plus 4x is 6x. Then I have negative 1y and positive 1y, and oh, that's unexpected. Those cancel. They give me 0. My z's are positive 1z and negative 1z, so those cancel. So I didn't expect for 2 of those variables to cancel, but believe it or not, this is a good thing. That's actually going to make less work for you. So then for our constants, we have 4 plus 14 is 18. Now, because 2 of our variables canceled, that means we can actually go ahead and just solve for x right now. I don't have to write a new 2x2 system to solve using the step 2 that we talked about up here. So step 2 is going to be shortened because 2 of my variables canceled, which makes it very easy to go ahead and solve for x right here. Now, in order to solve for x, all I have to do is divide by 6. So that's going to give me x equals 3. Now, I do technically still have a 2x2 system, but all I have to do to solve for that other variable, my y, is take that 3 that I got for x and plug it back into equation 4. So I'm going to go ahead and rewrite equation 4. And that was 3x plus 2y equals 15. And now I'm going to take that 3 and I'm going to plug it in for x. So that's going to give me 3 times 3 plus 2y equals 15. So then I've got 9 plus 2y equals 15. And then I can solve. So I want to subtract the 9 first, which is going to give me 2y equals 6. And then I can divide by 2, and that gives me that y equals 3. All right, so I now have 2 variables already. So I got to skip some stuff in the middle because I got lucky and 2 of my variables canceled. So now if I have x and I have y, the only thing I have left to find is z. So I'm going to go back up to my originals, and I'm going to pick one of these equations that I want to use to plug in x and y and to solve for z. So since I'm solving for z, I'd kind of like for my z to be positive. This is the only equation that has a positive z, so that's the one I'm going to choose to plug into, equation 1. So I'm going to rewrite equation 1, and that is 2x minus y plus z equals 4. All right, once I have it rewritten, I'm going to go down here, and I know that the x is going to get plugged in here, and the y is going to get plugged in there. So that gives me 2 times x, which is 3, minus y, which is also 3, plus z equals 4. So then 2 times 3 is 6. Then I have minus 3 plus z equals 4. Then I can go ahead and combine those together. So 6 minus 3 is 3. So 3 plus z equals 4. And then the last thing is to subtract that 3 on both sides. And then that gives me z equals 1. So I have x, y, and z. I'm ready to write my answer. So x y, then z. So x is 3, y is 3, and z is 1. So there's my solution, and again, if I take those values of x, y, and z and I plug them into the original equations, do all the math, the first one should come out to equal 4, the second one should come out to equal 11, and the third one should come out to equal 14. And that's how I know I have the answer correct. So this was a long lesson, and the problems are a little bit lengthy. But like I said, you need to make sure that you go slowly and carefully. The worst thing you can do is rush. If you rush, it is almost inevitable that you will make some little math errors that will frustrate you terribly. Take your time, go slowly and carefully, and you can do it.